Welcome back, fellow survivors, to the Walking Code C++ programming. This is going to be the lecture portion for Lesson 9, The Power of If. Alright, and we're going to see in this lesson, we're going to learn the difference between true and false as it pertains to computers. We're going to learn how to use relational operators, meaning how we test data within our programs to see either it meets certain criteria or it doesn't meet certain criteria. And we see things like this all the time, every day. Like you have to be over 18 or over to smoke, you have to be 21 or over to drink alcoholic beverages, that type of thing. And then we're going to find out how to use if statements in our programs. Alright, so the difference between true and false. Now we know that we can store true or false values in Boolean variables. Right? If we go back to a couple videos about data types, Boolean variables can store either true or false values. You don't actually store the word true or the word false in the Boolean variable. Generally, you store either a 0 or a 1 for binary, 0 being false and 1 being true. That type of thing. But for our purposes, we can say it's true or false. Alright? And relational expressions always evaluate as either true or false. And maybe if you've taken algebra or something like that, you know that, if I say x is greater than 3, well, I know x is either 4, 5, 6, 7, 8, all the way up to infinity. Right? That type of thing. So, relational expressions use relational operators to calculate whether the statement is true or false. And then we can have our program execute a block of code if the statement is true, and we can also have our code execute a block of statement if a block of statements if the statement is false. Okay, and this is kind of easier to see than it is to talk about. So we're going to look at the relational operators. All right, now these operators are probably seen in algebra. Example up top side here, the operator two equal signs means equal to. So in C++ and some other high-level programming languages like Java, C#, that type of thing, you're going to see two equal signs meaning equal to. So I'm testing if one value is equal to another value. Alright, the reason we use two equal signs is for comparison. One equal sign means assignment. So if I say x equals 3, I'm saying store the value of 3 in the variable x. If I say x equals 3, then I'm testing the value that is stored in x to see if it is equal to 3. Alright, and we can see that we have our sample over here where 7 equals 7, or does 7 equal 7, and this statement is true. The not equal to, meaning I'm testing to see if a value is not equal to another value, is the exclamation point and the equal sign. Alright, and in the sample here, these are just for sample purposes, I can see is 7 not equal to 7. Well, that statement is false because 7 is equal to 7. I have the greater than symbol. Is 6 greater than 2? Well, yes, it is. So this statement is true. I have the less than operator. Is 7 less than 4? No, it is not. So that statement is false. Greater than or equal to. Is 6 greater than or equal to 6? Yes, it is. 6 is equal to 6. And that's true. Now up here, let's go back to greater than. If I just had the greater than symbol here, is 6 greater than 6? That would be false because 6 is equal to 6. Less than or equal to, is 3 less than or equal to 5? Right? Well, that should be true. I don't know why that's messed up here, but that should be true. Let me change that right now. I don't know how that happened. Let me go down to here and let me change it there. And that is totally my fault. Nothing like fixing something in the middle of a video, but that's fine. Didn't take that much to do that. So is 3 less than or equal to 5? That is true. Alright, the next slide. Hopefully we don't have to fix anything on the next one, but let's find out. Alright, a simple example of an if statement in C++ is if true equals true. Alright, we got two equal signs for comparison here. Alright, if true equals true, well, then what's going to happen? Well, what's going to happen is all the code that is contained within these two curly braces. In this case, I just have one statement in here, and it's a cout statement that says this prints with 2 exclamation points. Okay, well, true is always going to be true, so it's always going to print. But this is just a simple example. I really want you to get the syntax down here because we have a couple of other things going on. We have our condition in parentheses, and we have our code that executes in curly brackets. Notice a couple of things here. There is no semicolon after the closed parentheses. There is no semicolon after either one of the curly brackets. Don't do it. Your code will do all kinds of messed up things. If it does compile, it'll do all kinds of messed up stuff. We don't want to do that. The only semicolon that we have in this code snippet, and it's called a code snippet because we don't have the main function or system pause or return 0 or anything like that, is the only semicolon we have is after the cout statement here. Alright? So just keep that in mind. A lot of beginning programmers make that mistake. They put a semicolon at an open curly bracket or a semicolon after a parentheses, and it just screws up their whole code. If it does compile, it doesn't work right. If it doesn't compile, you sit there and you try to track down the error for hours, and it's just you put a semicolon where you didn't need a semicolon. Alright, here's a relational example. If 2 is greater than 3, then what we're going to do is cout this prints. Well, this is never going to print because 2 is never going to be greater than 3. Okay, so this block of code here will never execute, even if there's a million statements in this code here. You can have more than one statement. You can have as many as you want. Okay, but this is never going to execute because 2 is never going to be greater than 3. We can even test variables using our if statements. I have an integer x that's equal to 10. I'm assigning the value of 10 to the variable x. I only have one equal sign. If x is less than 7, then cout this prints. Well, this isn't going to print because x is equal to 10. Unless I change the value of x before this if statement here, right? This is never going to print. Alright, notice I just have a semicolon after my variable declaration and initialization, and after my cout I do not have a semicolon after the closed parentheses or either one of the curly brackets. I just want to emphasize that many times. Alright, so our program for this lesson is going to give us based on the number of zombies that are present. If the number of zombies is 0, we're going to go ahead and proceed into the area. If the number of zombies is 1, we're going to take it out quietly, come up behind it, and pop it in the head. If 5 or less zombies here, we're going to try to avoid this group, maybe skirt around it or something like that, because we don't want to take that many zombies on at once. If we see a herd of 6 or more zombies, we're going to get the heck out of there. Right? We're not even going to mess with them. We're not going to try to skirt around them or anything like that. We're just going to get the heck out of Dodge. Alright? Alright, so we're going to come back to the lab portion of this lesson. I hope you find it informative and exciting to see what happens when we code during the zombie apocalypse. Again, my name is Adam Veazey. Thank you for watching.